3/4 inch MDF base, 3/4 inch maple dowels. So this is a really dense wood. We did those pockets in the base in the exact same diameter, so it wasn't a slip fit. You had to hammer it in, but because this has a higher density wood, it'll compress the MDF and fit in there. And then we have 6 1/4 inch rings. If I only have one ring, so again, the point of this game is to move all these rings onto another peg in as few moves as you can. Okay? And the constraints are you could only move one ring at a time, and you cannot put a larger ring on a smaller ring. So let's go ahead and start with just, if I have one ring, how many moves could I do it in? One, right? If I have 2 rings, how many moves could I do it in? 1, 2, 3. Over there. So if I have one ring, so this is X, this is our variable X, and Y is the number of moves, I could do it in one move. If I have 2 rings, I could do it in 3 moves. If I have 3 rings, I could do it in, is it 6? I could do it in 1, 2, 3, 4, 5, 6, 7 moves. So 3 rings, I could do it in 7 moves. 4 rings, I could do it in, why don't you figure it out? Why don't you figure out the least number of moves you could do with 4 rings, and the least number of moves you could do with 5 rings, and 6 rings. Okay, so with 5 rings, we're able to do it in 31 moves. With 6 rings, we're able to do it in 63 moves. The way I do this is I actually have this algorithm in my head that I remember, and it is, if it is an even number of rings, I go 2 doors down, 1, 2. If it's an odd number of rings, I go 1 door down, 1 peg down. So there are 6 rings here, I go 2 down. There's 5 rings, I go 1. There's 1, I go 1. There's 4, so how far do I go down, Carson?
2.
2. Now I have 3 rings, how far do I go down here? 1. I have 3 rings, how far do I go down? I have 2, I go down. So what I'd like you to do in your spreadsheet right now is just create a column, title it X, wait a second, and then write in this data, and then create a column Y, and write in this data.
Okay, I'm in Google Sheets, which is a spreadsheet, works just like Excel. I have the kids enter the number of rings as an independent variable X. So our game has 1, 2, 3, 4, 5, 6 rings, and then the number of moves. They figure this out. Up here it starts to take a while. After they've entered this data, I select all of the data, making sure they understand why the number of rings is on the horizontal axis X, and the number of moves depends on this value. So I select the data, I go over here to table, I select a table, I hit insert, I can make that table a little bit smaller. So this is kind of the introduction in the spreadsheets and data, X and Y variables. And then on this table, you could do as much as you want, but if you go to advanced edit, one thing that they must do is title it number of rings versus number of moves. They also must label their axes. So what's down here, horizontal axis, again, is number of rings, independent variable, and vertical axis is changed right here to left vertical is number of moves. Okay, so there's my data. I could see it's an exponential function increasing at an exponential rate. Hopefully they could come up with the equation from this. This helps a lot getting the graph. You could do a regression on it. And then from there they could actually figure out if I have 7 rings, then that should be equal to the equation. So I hit equals 2 to the power of n minus 1, 127, which is right. If I want to put all these in the center, This centers them up there. So if I have 8 rings, let's see if this equation works. Enter 9 rings, 10 rings, 11 rings, and so on. So these are all centered up. So if I click on here, I should drag that equation down, and it enters all of those data points as well. So I can see it's an exponential function with a base of 2. So that's the first thing I do on the spreadsheet. So this is about independent, dependent variables, graphing, functions, exponential rates of change. Then the next thing I do on the spreadsheet is I create a materials list. So here I list out my parts. There's the base, the MDF base. There are the dowels times 3. And then here's my 1, 2, 3, 4, 5, 6 rings in decreasing order. I have my scale is in ounces. I weigh all of my parts in ounces. This is the sum of the 3 dowels. These are the individual rings. And here's a one-dimensional length. But this is the radius of the part. There is no radius on the base, so it's x. Radius, they're 3/4 inch dowels. So half of that is the radius. 4-inch ring, the radius is 2. And this is also a one-dimensional measurement in inches. It is the height of the part. My base is 3/4 inch MDF. My dowels are 2.5 inches. And then my rings are all 1/4 inch plywood. In this case, they're actually MDF, but the one I did this was plywood. Then I find the surface area of the part. And you could do as many equations as you want on here and include as much as you want. I really have very different levels of math in this class. So I just do this as a rectangle minus the triangles. But if you wanted, you could subtract the volume of that cylinder, of the pocket that this goes in, 1/2 inch. So this is an equation, base times height minus the 4 triangles of 2. This is the equation of the dowel. So this is pi r squared, and I select my radius from here. And I do that because I'm going to use this equation down here. So I select this equation and drag it all the way down, and that gives me all of my others pulling in the cells from the radius. Again, I did not subtract that interior circle, just kind of simplify the whole thing, but you can make it as complex as you want. So I have linear measurements in 1D, right, both the radius and the height. Then I go to 2-dimensional space, surface area. And then next I do the volume, which is 3-dimensional space. So I just highlight that this is in fact 3-dimensional space. My units are cubic inches. 2-dimensional space, my units are square inches. 1-dimensional space, my units are inches. So my volume of my base, I use an equation. I take my surface area times my height, and that gives me volume. This is also an equation for the dowel, and it's same thing, surface area times height, and then all of them are actually the same. So volume is going to be the same equation for all of them. Next column over here is the density, which is mass in ounces divided by volume in cubic inches. So this is an equation. I do it as weight divided by volume. And then I drag that down to all of them. It's the same equation for all of them. And I could see that the MDF base has the lowest density. That's what I would have expected. All the plywood rings are all pretty close to about 1/2 ounce per cubic inch. A little bit of variation. This one's the furthest off. And then that hardwood maple is really high. That's actually too high. Maple is certainly not almost 4 or 5 times dense as MDF or plywood. My mistake is right here. In my weight, I did the weight of 3 dowels. So it's a great check. Again, you could do displacement to check displacement, water displacement in a beaker to check their volumes. Okay, and then this is what your portfolio should look like for the Tower of Hanoi. Here are your notebook drawings first. Then here's your working drawing, your DWG. That's upside down. Some of your layouts are a little crowded and oriented wrong, but this is your Mastercam file on how to cut it out. So we have 1, 2, 3 parts. Right here is where your spreadsheet goes. The fourth part and the fifth is a nice photo shoot of your built project.